Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome back to NPTEL online course on logistics and supply chain management. So in the last session we started discussion on transportation problem programming, and we have seen that there are basically two phases. We need to find out first the initial basic feasible solution, and then we will go for the optimality, right. So we discussed about the three methods how we can get the initial basic feasible solution, and in detail we discussed about the northwest corner method. So here we will discuss about the second method, which is the least cost method, and we will try to allocate as many units as possible in that cell where the minimum cost is there, right, and then we will strike either the capacity of that factory fully in that particular row, or we will try to strike off the demand from that particular market, right. Whosoever is the minimum will strike off that completely, right, like we did in the last session while allocating using northwest corner method, right. So this is just a brief introduction about that, and you can just go through how we are doing that algorithm. I'll just go through the first step. Obviously we will check whether supply is equal to demand, means balanced problem. If it is not, we will go for balancing, right. So that we will discuss towards the end of this session. So like same question again I am repeating, we have three factories, we have three markets, and demand is also the equal demand, right. So that means 170 is the demand, 170 is the supply. So in that way it is balanced, we have seen in the last session as well. Now the algorithm says we need to find out the minimum cost cell, and we will allocate the maximum units as many we can do, and those units are restricted by either the supply or the demand. Whosoever is the minimum value, either supply or demand, will simply assign those many units, right. So now minimum cost cell, if I will see, is this one, 1 rupee per unit cost. So maximum unit, how many I can allocate? 40 is supply, 60 is demand, so I can allocate maximum 40. So in that way if I allocate 40, so 20 will be left here, and capacity the supply from Jaipur is fully exhausted, right. So what if there is tie between two cells? So then you find out in those two cells where you can allocate maximum. Let us say if one is there here also, so then you see where you can allocate maximum, but in this case also I think you can allocate maximum 40 only. So let us say if one is somewhere, if I will say somewhere here, right. So in that case how many you can allocate maximum? 60 is the supply, 60 is the demand, maximum you can allocate 60. So you will not allocate in this cell, in that case you go for Udaipur factory first, right. So minimum cost, but if it is tie you can break the tie in this way. Now this is fully exhausted. Now next minimum cell is this one. How many I can allocate here maximum? Demand is 40, supply is 70, I can allocate 40. In that way this Pune market demand is totally met, and this is also exhausted by 40 units. So rest supply is 30. Now next minimum cost is out of those cells which are not strike, right, strike off. So next is now 3, here 3, like we got the tie now. So how many maximum I can allocate here? In this case only 20, but in this case how many I can allocate? 60. So you make allocation 60 here because maximum. So if I will allocate 60, this Udaipur supply is totally gone, and here we are left with 10 more demand. So obviously then there is no option, 10 will be allocated here and rest of the 20 will be allocated here. This will be your total allocation if we are going for minimum cost cell. If I will ask you to calculate the cost, obviously from Jaipur to Delhi per unit cost is 1 rupee, total units we are transporting 40, from Udaipur to Kanpur per unit cost is 3, total we are transporting 60, then from Mumbai to Kanpur per unit cost is 6, we are transporting 10 units, from Mumbai to Pune per unit cost is 2 rupees, we are transporting 40, from Mumbai to Delhi per unit cost is 8 rupees, we are transporting 20. So if you can calculate what is the total cost, that will be total cost. So in the further slides, step wise I have given you same steps which I have done, so you can just use that, right, and you can see this is the total allocation, whatever we have done, same allocation. Okay. So now the transportation cost again is 480. So alternate solution, if we have tie in selecting minimum value, see like we were having tie, I think in this solution they have I allocated 60 all the units in this cell only, they allocated 40 and 20. Now there is tie. So tie means, what is the meaning? That means I can transport either fully 60 units from Udaipur to Kanpur, or I can transport maybe from Udaipur to Delhi 20 units. Now it depends upon, again, then you can pick which option you want to pick, because whatever option you will pick, the cost will be same, right. So that means instead of one optimal solution, now you are having two optimal solution. Two optimal solution means you have more than one options, and all the options are giving you minimum cost. So in that way you are at win-win position, that still you can pick out of those different options, right. So this is the meaning of how we can break the tie. Next is your Vogel's approximation method. So if I will read all the steps, maybe little confusing, so I will just go through explaining the numerical, and that is the best way how you can go. This is also known as penalty method. When saying a penalty means, what if we will not allocate into this cell? If we are allocating in some other cell, what is the penalty if we will allocate into some other cell? Maybe the opportunity cost we need to calculate, right. So again the first step is we need to find out whether the problem is balanced or not, supply is equal to demand or not. Same problem again we are going for. Now here the step is, we will, for all the rows and for all the columns, we will subtract the minimum value, minimum cost from the next minimum cost. In one row we will find out all the values, what is the minimum cost, and next minimum we will find out the difference, that is row difference. Here we are writing row difference, and same will do for all the columns. Here we are writing column difference, right. For first row minimum value is 1, next minimum value is 4, difference between 1 and 4 3. Here minimum value is 2, next minimum value is 6, difference is 4. This is how we will find out the row difference and column difference. What if we have two same minimum value, means one is repeating 2 times and that is the minimum value, then the row difference will be 0, right. Now once it is done for all the rows and columns, we will find out the highest penalty. In this case if you see, highest penalty is 4. Row difference or column, whatever, either it is the row value or the column value, whatever is the highest, you will pick that. What if there is a tie? You will break that tie, you will find out where is the minimum cost, and you do the max. Even then, first point to break the tie is you find out where is the minimum cost cell. Then if minimum cost cell is also same for 2 rows, let us say, then you will break the tie again, find out where you can allocate maximum. If the maximum also you can, there is tie, right, maximum 10 you can allocate in both the cells, then arbitrarily you can pick any of the cell and do the allocation. So 3 steps I have told you how you can break the tie, but here there is no tie. We can see the 4 is the highest row difference, so we need to allocate the demand we need to fulfill in this particular row. Now what is the minimum cost in this row? The minimum cost is 2. So we'll allocate maximum number we can allocate in this particular cell. How many maximum we can allocate? I have told you, you check the supply, you check the demand, whosoever is the minimum value, those many units you can allocate. So 40 is the minimum value. After utilizing this 40, the Pune facility is totally gone, market is gone, and here you are left with 30. Now the next matrix you will not include this column, and again you will repeat the first step. You will find out the row difference, you will find out the column difference, but don't skip this step. Just imagine that the difference will be same. No, because now the one column is deleted and many cells are deleted in the row as well, right? So that means your row difference or column difference may change. After doing that, the second step, now we are left with 3 by 2 matrix, right? 2 by 3 matrix. Now again we will find out the row difference, column difference, and again the maximum value is here. We will find out the minimum cost value is 1, and we will try to allocate the maximum is 40 we can allocate, and this now Jaipur facility is also gone, and we are left with Delhi 20 demand. Again this is 2 by 2 matrix. Again we will find out the row where is maximum penalty is 5, so we will allocate maximum here. So we will keep on doing this same process until we will allocate all the supply to all the markets. This is your Vogel's approximation method. So once it is done, you can see this is how you have done the allocation. Again same way you will find out the total cost. In this case the cost is 480. So incidentally this happened that here all the 3 algorithms gave you 480, but usually your Vogel's approximation method is efficient than your minimum cost method and your northwest corner method, right? So it is usually more preferred than other 2 methods, but anyway you use any of the method, but the next step is fixed. We have to go for the optimality of the solution, right? So this is how we have discussed all 3 methods you can use to find out the initial basic feasible solution. Now next is optimal basic solution, and how we can use this. This is modified distribution method, short term is MODI method. We use this to find out the next stage optimal solution. So first we have done that, we found the initial basic feasible solution. Now we will find out this MODI method is based on the opportunity cost method. So let us say if you are saying that factory 3 will supply to market 3 and market 4, what is the opportunity cost if we will say factory 3 will supply only market 5? Let us say total cost of supplying these 2 markets may be 100 rupees, but here it is 90 rupees. That means if we will shift to this alternative, we will save 10 rupees, right? So this is how this algorithm is working. We will keep on iterating the solution until we will found that minimum cost transportation cost solution, right? So just we will go through. This is the cell with most significant improvement potential is identified. Update the allocation. If we have done some allocation earlier using the initial basic feasible solution or maybe MODI method. MODI method also not giving in one iteration. Maybe sometimes you are running more than 5 iteration to get the solution. 5 iteration means earlier you made allocation in x13 maybe 5. Now you are deleting it and you are making x23 5, right? So reallocation you are doing because that is giving you lower cost. So what are the steps? We will find out the initial basic feasible solution by using any of the method. Then to go for optimality, first we need to check whether we have these many allocations, m plus n order of matrix minus 1, right, and whether these are at independent location or not. These allocations are at independent location or not. Now there is the point. When we talked about initially some definition in the last session, I talked about the degeneracy, feasible solution, then I talked these should be non-negative allocation at independent position. Quickly I will go back and I will tell you this. Let us say this is the example. Now allocations are here, 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 here. All these are non-negative. Yes, these are non-negative, no negative allocation, 40, 30, 40, 40, 20. There is no negative value. Are at independent position. That means how you will define independent position? You start from any occupied cell, you can take turn from other occupied cell, and there should not be any closed loop, right? You see, if I will start from anywhere, I can take turn here, I can take turn here, I can take turn here, still I am not able to make the closed loop. Let us say if the allocations are like this, let us say one is allocated here, another is allocated here, another is allocated here, another is allocated here, another is here, one here. So see, if I will start from the allocated cell, if I will take turn from here, I cannot take turn anywhere, right? So no closed loop. If I will go here, then take turn here, then here, another turn, that means closed loop. So this is not at independent position. So this is the meaning of independent position. If I will start from occupied cell, I can take 90-degree turn only at the occupied cell, right? So there should not be any closed loop. If closed loop is there, that is not independent position. This is how we can test whether the allocations are done at the independent position or not. And we will check if these are independent, we can go for optimizing the solution by implementing Modi method. And how we will do that? Again we will find out the set of values ui and vj. If we will again discuss these steps, will be little difficult to understand, but only thing I will try here just communicate to you that we will try to find out the opportunity cost, and if opportunity cost is lowering the total allocation cost, we will go for that solution, that will be the optimal solution, right? And then we will check whether optimal solution is reached or not. These three conditions are there, but right now do not go for this. I will just start solving the question with the numerical and will understand it in a better way, right? So till now we have for check this, you need to ensure, as we were doing that before applying the initial basic feasible solution, we were checking whether your problem is balanced or not. Same way, while processing for the optimal solution, we need to check whether these are non-negative allocations and are at independent position, right? Now this is the allocation, right? So now we will find out ui and bj. What are ui and vj? Vj means for all columns you are assigning these variables v1, v2, v3, v4, v5. How many columns are there? You will assign those many values. Similarly, for all rows you are saying u1, u2, u3. Now these are those cell costs which are occupied. You can see in the last this numerical, this is occupied, this is occupied. Occupied means where we have done the allocation. So we are not considering other cells, we are just considering these occupied cells. We will calculate these uj's and vj's and ui for all occupied cells, and then we will do the cell evaluation for all unoccupied cell, right? So we will develop all the equations. So here you can see this cell is made up of u2 plus v1. So v1 plus u2 is equal to 3. This is made up of v1 plus u3 is equal to 6. This is made up of u3 plus v2 equal to 2. This is made up of v3 plus u1 equal to 1. This is made up of v3 plus u2 equal to 3. All these occupied cells. So 5 occupied cells, we got these 5 equations. Now we forgot to check that whether we have m plus n minus 1 allocations. What is m? Order of matrix. So we have 3 columns, 3 rows minus 1 is equal to 5, and we have 5 allocations, 5 number of allocations. That means this condition is fulfilled. Second condition is these should be at independent position. Whether I can draw any closed loop? No, I cannot do that. Here also I cannot do that. No closed loop. So that means these allocations are at independent position. Only once it is at independent position you will start calculating these equations. Before that you cannot do that, right? Now we got 5 equations. To solve these equations, you can put any of this variable, one variable equal to 0. Let us put V1 equal to 0. If I am putting V1 equal to 0, that will give me U2 is equal to 3 from here, sorry, U2. From here I can calculate that. If I will put V1 0 here also, U3 will be 6. Because I got U3, I will put here V2 value will be 2 minus 6 minus 4. So from here you can see we got V3 somewhere, no, we got U1, leave it, V3 U3, we got V3, we did not get V3, we got U3, yes, we got U3, U3 is 6. So from U3 is 6, V3 will be minus 3. Now we got V3, this equation also we can solve, U1 will be 4, 1 minus minus 3 will be equal to 4. So put any of this variable equal to 0, you can solve rest of all equations to find out. Now we got the value of V1, V2, V3, U1, U2, U3, right. You can write these values like these are the equations I solved already, and this is how you found all those values. Done. Now what is the next step? Now these variable we found, we will find out these opportunity cell cost for any cell. This value will be Cij minus Ui plus Vj. Ui Vj we got, Cij initially cost per unit is given, we will find out for all unoccupied cell, only for unoccupied cell. So we will not consider these cells now. If we will do that, you can see this initial cost is 4 for the first cell, you can see for the first cell it is cost 4. For this it is 5, 4. So you can check 4, 5, 4, 8, right. Now this is U1 and V1. So U1 value is minus 5, V1 value is 6. So we will do, this is opportunity cost, we are calculating opportunity cost as I told you, Cij minus Ui plus Vj. So for this cost 4 minus bracket minus 5 plus 6, this is 3. Similarly we will find out this, similarly we will find out cost, opportunity cost for this cell, similarly we will find out opportunity cost for this cell, right. So all unoccupied cells. Why we did not calculate for these cells? Because these are already occupied. We are finding whether any new cell is available for allocation, and if we will allocate there, the total cost can be further reduced, right. So now there is condition, if all these opportunity cost we are calculating, in maximum books it is represented by Dij, whatever is this is Dij, right. So I am saying this is opportunity cost. If these opportunity costs are all positive, that means this is optimal solution and you need to stop iterating this because this is the final solution. If any of Dij is negative, that means this is not optimal. Negative means if this value is negative minus 2, that means if I will allocate into this cell, transportation cost will further be reduced, because minus 2 is the opportunity cost. So if I am getting all positive, at least one 0, that means 0 means that is optimal solution. But if I will allocate into 0 opportunity cost cell, that is another alternative I am getting, but total cost will remain same. So all three conditions clear, right. So because in this question, because all Dij are positive, so this is the optimal solution, no need to go for further solution. So these all you can check the condition which I told you, and in negative we need to go for iteration. I will pick one numerical where we will see if what if we will get one negative value, right. So quickly we will go for that numerical. First, this unbalanced problem. From the first session we started discussion on this transportation problem. We said the first step is the problem should be balanced, that means total number of supply should be equal to total number of demand, but in this case you can see our supply is 170 units and demand 95 units. that cannot happen, we cannot go for optimization. In this case, how we will go for making this problem balanced? We will add one more dummy market, and for that market we will keep the demand whatever is the difference. Like here 22 is the difference, we will keep that demand with 22 difference. Now if you will ask me what will be the cost, cost will assign 0, 0, 0. This is just to represent dummy market so that we can go with the linear programming problem just for solving this problem, right? Otherwise there is no, when we are making allocation to this particular market, dummy market, there is no meaning, right? Because that extra supply is always extra, right? We are not able to consume that, but yes, we need to show that somewhere in our calculation. That's why we are adding the dummy market. You can see here we have added one dummy market where 22 whatever is the extra. This is not only that you need to add dummy market only. Sometimes if we need to add supply source, maybe S5, 4 supplies are already there, so then we will, whatever is the extra demand, we will exhaust using that supply, right? And again the cost will be 0 in all the cell. And then you will ask me, when we will make the cost 0, so 0 low cost least cost method if you will go for, obviously you will allocate into this cells first. So what you can maximum, how many you can allocate? 22. So that is anyhow we need to allocate because that is extra we need to consume. So now we will go for one problem where if we are getting some opportunity cost negative, so in that case what we will do? So this is another problem, this is per unit cost, transportation cost, this is the total supply. If you will sum up, I think this is 340, and this if you will sum up, see this is done here, so 340, that means this is a balanced problem. So first point is done, that the problem is balanced. Now we can go for the allocation, and here least cost method is applied. So we have picked the least cost cells and we have allocated like we discussed in the first example, how we can go for the least cost method. Variable is the least cost. If I will just repeat few steps, here this is the least cost. Maximum how many we can allocate? 50 we can allocate, because maximum demand from market B is 50 only. So while allocating 50, this is completely gone and we are left with the 50 supply. What is the next least cost? 2. Here also 2, but this column is already exhausted, we cannot make any further allotment in this cell. How many we can allocate maximum in this cell? We can allocate maximum 50. After allocating, we are left with 20 more demand, but this supply is totally gone. This is least cost method. We have already done that. So you can just repeat all those steps and you can make the allocation. Total cost is 1410, right? Now to go for optimal solution, first we need to check whether we have done m plus n minus 1 allocation. So here m, total number of columns 5, total number of rows 3, minus 1, so you can see 7. So whether we have done 7 allocation, 1, 2, 3, 4, 5, 6, 7. So that means we can go for applying the MODI method for getting the optimal solution. Now what is MODI method? We need to assign ui plus vj. So that ui, u1, u2, u3, vi, v1, v2, v3, v4, v5, right? And how we can calculate that? We have seen that for occupied cell. So for this cell, this is occupied, u1 plus v2 equal to 1. For this cell, u2 plus v3 equal to 3, whatever is the cost, right? Like we explained, I have already explained in the last example. So with this you will come up with all the equations. So here 7 equations you will come up, you keep any of the variable equal to 0 and then you can solve all other equations. While putting that, you can get u1 minus 1, u2 0, 1, similarly you can find out all the vj components. Now what we need to do? We need to find out the opportunity cost of the unoccupied cell. Dij is equal to Cij minus ui plus vj. we will find out for all unoccupied cell. So you can see for all unoccupied cell, if we will find out, so here those values are missing. So let us find out here only. So this is 4, right? Yeah, I have written here. So this is 4. So cost is Cij is 4 minus what is the value of U1 minus 1. What is the value of V1 plus 6. So this is total your 5. So value is minus 1. Let us calculate one more. This Cij is 9 minus U1 is minus 1 plus this is made up of V5 7. This will give you 3. So 3 is the cost. So here I have written the opportunity cost for all the unoccupied cell. Now what is the next step? We need to find whether all these are greater than 0. That means positive, then it is optimal solution. Any single value is negative or more than 1, that means not optimal. In this case we are getting minus 1. One negative value, that means this solution is not optimal solution and we need to find the next optimal solution. What if we will reach to this point? Now we need, what is the meaning that this solution is not optimal, we are getting negative value? That means if we will allocate into this cell, right now there is no allocation into this cell. If we will allocate into this cell, then the further cost can be reduced. So how many units we can allocate into this? That we need to decide. The step is we need to start from this cell. Again we will draw the closed loop and we will take a turn only at the point where the already you have allocated the units. So this is the only possible path we can go and reach back to the same cell, right? Now from where we started we will assign positive and alternatively we will assign the sign, right? That means positive, negative, positive, negative. Okay. So again how we draw this closed loop? We will start from that negative opportunity cost cell, we will take a turn only at the occupied location and then we will try to draw the closed loop, right? And now we will allocate positive and negative alternative signs. We will allocate positive on the first where we started tracking the path, then at the next turn we will assign negative, then positive, then again negative. Now out of these values we will take the negative values where we have assigned a negative. So which one is the minimum? We will add that minimum value where we have assigned positive sign and we will subtract that minimum value where we have assigned negative sign. That means what is the minimum value out of these two? 50 and 10. Minimum is 10. That means 10 we will add here, 10 we will add here in this cell, we will subtract 10 here, we will add 10 here. That means the new allocation will be, this cell is going to be empty, we will allocate 10 here, from 50 it will be 60, from 20 it will be, 20 we are adding 10, it will be 10, from 50 it will be 40. So next allocation you can see this is how the closed loop path is done, and while adding 10 here, 10 new allocation will be done, here it will be 0, here we will add 10, so 30 will be there, here we will subtract 10, 40 will be there. So in totality there is no change in the number of units, this you need to keep in mind. We are adding, we are subtracting the same number of units, this is the new allocation. Earlier we were having 10 here, now that is shifted to here because it was minimizing the cost further. Now again we need to go for checking whether this is optimal or not. One iteration we have completed. So before going for that, whether m plus n minus 1 allocation, yes, 1, 2, 3, 4, 5, 6, 7 and order of matrix is 8 minus 1, 7. So independent location, any location you start, can you track close path? You cannot do that. Yes, you cannot do that. Here also you cannot do that. So these all are at independent position. Now again you find out u1, u2, u3, v1, v2 up to v5. Again same procedure by taking the cost of the occupied cell and then find out the opportunity cost for the unoccupied cell. So again, if you will go for U1, U2, U3 these values, and then for unoccupied if I will calculate, so this is 6 minus this U1 1 plus 4, this is 1. Likewise I can calculate 4 minus 1 minus 1, this is 2, right. So you can see this is how we have calculated all the opportunity cost, and all opportunity costs are greater than 0. That means all are positive. So this is the optimal solution, because if you will change the allocation from here, this is not going to minimize the cost. So this is the optimal solution, right. So this is the complete numerical you can see, and total cost is 1400. Earlier we were getting somewhere I think 1410. So this is how you can minimize the total transportation cost. This is the minimum cost possible, okay, with that setup. So this is the complete algorithm how we can apply transportation algorithm. So advantages, quickly go through. Competitive advantage, obviously we will get the competitive edge by reducing the cost, improving the service level. See, when you are reducing the transportation cost, that means you are reducing the lead time as well. Somewhere you are reducing the cost, somewhere reducing the cost means distance somewhere you have minimized, right, and then per unit, so that delay on the during the transportation also minimized. So overall efficiency is improved, that will give you competitive edge. Cost minimization also will provide you extra margin, also will help you, to minimize the fuel expenses, vehicle maintenance, labor cost, everything, right. Improved services level, now you have reduced the lead time, so obviously services level are improved, because in minimum time you are delivering the services. Inventory also you can plan in a better way, because you know exactly when you are going to get the next delivery, and that with minimum cost. Resource optimization, because optimization algorithm we are applying, we are utilizing the resources optimally, so then resource optimization and time efficiency will be saved, because we are reducing the transportation distance and cost. So this is complete transportation algorithm. Again you can go for these books. I have taken numerical from these books, so you can just refer for further practicing. So that's all from transportation management. Thank you very much.